Oh, friends, today there will be simply an incredible tank. Stock up on tea and cookies. Imagine a tank with a height lower than the height of a human, only 174 centimeters. A turret inside a turret that rotates in the opposite direction. Homing missiles piercing half a meter of armor. A crew of 2 people, both sit in the turret. Hydropneumatic suspension instead of the usual one. And all this in one machine. But the most amazing thing about this tank will be at the end. The beginning of the 60s of the 20th century. The Cold War is in full swing. The Soviet Union and the United States are competing absolutely in everything. Space, aviation, navy, and, of course, tanks. By this moment, Soviet designers understand one important thing. Classic tank building is hitting a ceiling. Armor is becoming thicker and thicker, and ordinary tank shells are piercing it worse and worse. The calibers of guns are growing, but along with them, the recoil, the mass of the tank, and the dimensions are growing. Something fundamentally new is needed. And here an idea is born that seems ingenious. What if the tank shoots not shells, but guided missiles? The logic is simple and convincing. A missile flies farther than a shell. A missile can be guided exactly to the target, even at a large distance. A missile with a cumulative warhead will pierce any armor regardless of the caliber of the launcher. There is no need for a huge gun with monstrous recoil. A launcher of medium caliber and a missile control system are sufficient. The idea of a missile tank has been floating in the air for several years already. Different design bureaus are trying different approaches. Someone puts missile launchers instead of a turret, someone makes hybrid systems, but all these machines turn out either too big or too vulnerable or insufficiently universal. A tank is needed that will be small, invisible, maneuverable, but at the same time deadly dangerous. In 1962, the Chelyabinsk tractor plant receives technical specifications for the development of a prospective missile tank. Pavel Pavlovich Isakov is appointed as the chief designer. The head of SKB-75 is an experienced engineer who has already managed to work on several tank projects. Now he faces a task that borders on fantasy: to create a tank of the minimum possible height with the maximum powerful missile armament, and at the same time preserve mobility, cross-country ability, and reliability. The requirements are tough. The tank must be so low that it is difficult to notice and even harder to hit. It must carry guided missile armament capable of destroying any enemy tanks at long distances. It must be sufficiently fast and maneuverable to take advantageous positions and escape return fire. And all this needs to be fitted into a machine that will not cost like a spaceship, and which can be produced serially. Isakov understands that this task cannot be solved by standard methods. Fundamentally, new solutions are needed, and the first thing he starts with is the choice of the missile complex. Without it, it is impossible to move further, because the entire layout of the tank will depend on the dimensions and characteristics of the missiles. On the 30th of March, 1963, a decree of the Council of Ministers of the USSR is issued. Work begins immediately on 2 missile complexes, Astra and Rubin. Both are brand new, both are promising, both are capable of solving the task of destroying armored targets at large distances. Parallel developments, tests, and comparisons of characteristics are underway. Designers calculate dimensions, weight, reliability, cost. The military looks at effectiveness, accuracy, penetrating ability. On the 1st of March, 1964, A section of the Scientific Technical Council of the State Committee for Defense Technology issues a decision. Of the two complexes, Rubin wins. Work on Astra is officially stopped. Now the task is clear. It is necessary to create a tank around the Rubin missile complex. And here the most interesting part begins. Because Rubin is not a small toy that can be shoved anywhere. The guided missile of the Rubin complex has a caliber of 125 millimeters and a length of 1,505 millimeters. That is 1.5 meters, almost human height. The cumulative warhead is capable of piercing 500 millimeters of vertically positioned steel armor. The firing range is up to 4 kilometers, which is significantly more than any tank gun of that time. But the main problem is elsewhere. The control equipment of the Rubin complex occupies a volume of 200 cubic decimeters and weighs 180 kilograms. This is like 2 healthy refrigerators. Where to shove all this into a tank if one still needs to place the crew, the ammunition rack, the engine, the transmission, the fuel tanks? How to fit 1.5-meter missiles into the ammunition rack, how to ensure they're feeding to the launcher, how to protect all this complex electronics from vibrations, impacts, combat damage. Isakov starts with the main thing. It is necessary to radically reduce the internal volume of the tank. The smaller the volume, the lower the silhouette, the harder it is to hit the tank. The first decision, which seems insane but logical, is to reduce the crew to 2 people. Not 4, as in an ordinary tank, and not even 3. Only 2, the mechanic driver and the commander weapon operator. Automation must do everything else. There will be no loader. He will be replaced by an automatic loader that will feed missiles to the launcher. There will be no radio operator. The radio station will be placed so that the commander can use it. There will be no gunner either. The aiming of the gun will be taken over by the commander with the help of an advanced fire control system. 2 people per tank. It sounds like science fiction, but there is simply no other way to fit all the necessary equipment. The designers understand that there is still a lot of work ahead. It is necessary to design the launcher, develop the loading system, think through the placement of the ammunition load, create a fire control system, choose an engine and transmission, and design the chassis. And for all this, there is less than 2 years. Work is going at a frantic pace. Blueprints, calculations, mock-ups, tests of individual nodes. SKB-75 works practically around the clock. By the end of 1963, the technical project is ready. The manufacturing of the first prototype begins. Metal goes into work. Assembly shops receive parts. The final stage begins. Everyone understands that they are creating something unique. A tank that is unlike anything created before. A machine which, if everything succeeds, might change the very understanding of what a tank should be. 1964. The assembly shop of the Chelyabinsk tractor plant. Workers are assembling a machine that many of them do not even understand. The hull is unusually wide, but at the same time, frighteningly flat. The turret looks as if it was specially flattened by a press. No familiar high elements, no protruding hatches. Everything is maximally streamlined, maximally low, maximally compact. The design that Isakov and his team came up with truly borders on engineering madness. Let's start with the most important thing: how to place a crew of 2 people in the turret so that they can control the tank and fire simultaneously. Ordinary placement does not fit. If both sit side by side, the turret will become too wide. If one behind the other, too long. Some compromise solution is needed. the commander is placed to the right of the gun. In front of him are the fire control panel, sighting devices, controls for the Rubin missile complex. He is responsible for searching for targets, aiming the launcher, launching missiles, controlling their flight. In fact, he performs the work of 3 people at once: the commander, the gunner, and the missile complex operator. The mechanic driver is placed in a small turret, and here the most interesting part begins. In an ordinary tank, the mechanic sits in the hull, looks forward, and drives the machine. The turret can rotate however it likes. This does not concern him. Here, however, the mechanic sits in the turret, and when the turret rotates, he starts to rotate along with it. They turn the turret to the right. The mechanic also looks to the right. They turned it to the left. He looks to the left. Driving a tank in such conditions is impossible. The solution that the designers came up with looks like something out of science fiction. The mechanic driver's turret is installed in the right part of the main turret on a ball bearing. When the main turret rotates in one direction, the mechanic's turret automatically rotates in the opposite direction with the same speed. Result: the mechanic driver always looks strictly forward along the course of the tank's movement, regardless of where the main turret is turned. Imagine the complexity of this system. 2 independent rotation mechanisms working synchronously, but in opposite directions. The slightest failure and the mechanic will end up turned to who knows where, losing orientation in space. But there is simply no other way to place him in the turret and preserve the ability to control the tank. To protect the crew from radiation in the event of a nuclear explosion inside the tank, special plastic linings were applied. This is an additional layer that was supposed to weaken the effect of ionizing radiation. Every element is thought out with calculation for work in conditions of the use of nuclear weapons. Now, about how to make the tank maximally low. Standard torsion bar suspension has a fixed height. Ground clearance is constant. It cannot be changed. Isakov chooses hydropneumatic suspension, a fundamentally different system. By changing the pressure in the system, one can change the ground clearance of the tank. Why is this needed? Firstly, one can lower the tank even lower when it occupies a firing position. Smaller silhouette, fewer chances to be detected and hit. Secondly, one can raise the tank higher when it is necessary to overcome obstacles. A tank that knows how to squat and stand up depending on the situation. But hydropneumatics is also complexity. Hydraulic lines, cylinders, valves, all this requires maintenance and fears damage. The final height of the tank is 1.74 meters. This is less than the height of an average man. For comparison, the height of the American tank M60 of the same period is 2 meters 40 centimeters. The difference is almost 70 centimeters. Object 775 can be hidden behind such a cover, behind which an ordinary tank would stick out like on the palm of a hand. Now, about armament. The gun launcher D-126 was developed specially for this tank. Caliber 125 millimeters. The barrel is rifled with 32 rifle-ins. This is not a classic tank gun, but precisely a launcher. The missile does not need high initial velocity. It accelerates with its own engine already after exiting the barrel. The system can fire with 2 types of ammunition. The first is guided anti-tank missiles of the Rubin complex, a missile with a length of 1.5 meters with a cumulative warhead. After the shot, it exits the barrel, unfolds stabilizers 3 kilometers. Penetration of 500 millimeters of steel armor. The second type is active-reactive shells Burr with a high-explosive fragmentation warhead. These are unguided munitions for firing at unarmored targets. When it is a pity to waste an expensive guided missile, one can use Burr. Cheaper, simpler, and for many targets sufficiently effective. The gun is equipped with a semi-automatic loading mechanism and is stabilized in 2 planes by the stabilizer 216. This is critically important for guided missiles because the slightest deviation at the moment of launch can lead the missile away from the target. The engine, 5TDF, is a diesel with a power of 700 horsepower, the very one that will later be put on the T-64. With a combat mass of about 38 tons, the tank is capable of accelerating up to 70 kilometers per hour. For a machine of such mass with such a complex layout, this is an excellent result. The armoring of the tank is not the most outstanding. The frontal armor of the hull and turret is 120 millimeters. The sides and stern are thinner, but the main protection of Object 775 is not in the thickness of the armor, but in the low silhouette. The best way to protect oneself from an enemy shell is to make it so that you are not hit. A tank with a height of 174 behind a hill, behind folds of terrain, this is a very difficult target, and if one also takes into account that it shoots from 4 kilometers, then it becomes understandable why the designers bet precisely on invisibility. By the middle of 1964, the first prototype is assembled. The machine stands in the shop and, even against the background of other tanks, looks alien. A wide, low hull, a flattened turret, a short barrel of the launcher, a minimum of protruding elements. It truly looks like a tank of the future. The question is only one: will the tank itself have a future? Summer of 1964. Object 775 is taken out to the testing ground. For the first time, the tank drives out of the factory gates and immediately attracts the attention of everyone who sees it. The appearance really impresses even the military who have seen it all. The tank looks like an alien from the future. A flattened turret, a wide hull, almost complete absence of high elements. The silhouette is so low that it is easy to hide it behind a small mound. The designers are worried. 2 years of work, countless calculations, blueprints, tests of individual nodes. Now, all this has turned into a real machine that must prove that revolutionary ideas work not only on paper. The military commission is skeptical. Too many new solutions, too many deviations from the classic scheme. But it is too early to judge yet. One must look at the results. Sea trials begin. The engine, 5TDF, with a power of 700 horsepower, starts without problems. The tank moves from the spot, and it is immediately visible that everything is in order with mobility. On the highway, the machine accelerates up to 70 kilometers per hour. For a 38-ton tank with such a low silhouette, this is an excellent indicator. Acceleration is smooth, steering is responsive, the engine runs evenly. The hydropneumatic suspension works as intended. The tank can really change ground clearance. Pressed a lever, the machine squatted, became even lower. One more movement. The tank rose, increasing the clearance. It looks unusual, even fantastic. A tank that knows how to squat. On the testing ground, such machines have not been seen yet. The cross-country ability also impresses. Due to wide tracks and successful distribution of mass, the tank feels confident on soft soils. It passes where an ordinary machine would get stuck. The low silhouette gives one more advantage. The tank is harder to notice, harder to hit. From the point of view of camouflage, this is an ideal machine. The military observers exchange glances. Mobility, excellent. Invisibility, excellent. Cross-country ability at a height. Everything looks promising. And then the firing begins. And this is where problems surface that the designers preferred not to think about. The first problem is visibility, or rather, its catastrophic absence. The crew sits so low and so tightly packed inside that the view is simply murderous. The commander sees the world through narrow observation devices. The field of view is limited, as if looking through a keyhole. The mechanic driver, sitting in his rotating turret, is generally practically blind. Observation devices give a minimal view, driving a tank in battle, orienting on the terrain, noticing threats. All this turns into torture. Yes, the tank is difficult for the enemy to notice, but the crew itself sees almost nothing. Imagine that you're driving a 38-ton machine practically blindly. Any crater, any obstacle, any slope can become a surprise. In the conditions of the testing ground with cleared paths, this is still tolerable. But what will happen in real combat, in dust, smoke, under fire? The crew simply will not survive. The military make notes in notebooks. This is a serious problem, very serious. But maybe firepower compensates for the lack of visibility. They begin firing from the Rubin missile complex, and here the second problem crawls out, even more critical. The missile guidance system works disgustingly. The electronics of the early 60s have not yet reached the necessary level of reliability. In the ideal conditions of the testing ground, when there is no interference, no enemy fire, no dust and dirt, the missiles more or less fly where they are needed. But even here, the percentage of failures is frighteningly high. Out of 10 launches, 3 to 4 end in failure. The missile goes to the side or falls altogether, not having reached the target. And what will happen in real combat when the tank shakes from explosions? When there is dust, smoke, shrapnel in the air, when the crew is under stress, reliability will drop to zero. This one flew into nowhere. Second attempt. The missile did not exit the barrel. Failure of the launch system. Third attempt. It seemed everything was normal, but in the middle of the flight, the control signal disappeared. This is not a weapon. This is a lottery. Lucky, unlucky. The military look at this and shake their heads. For such money, for such complexity, to get a system that works every other time, this is unacceptable. A tank must be a reliable weapon and not an experimental toy that can fail at the most critical moment. The third problem is maintenance. The tank is stuffed with electronics, hydraulics, the most complex mechanisms. The rotating driver's turret requires constant adjustment and lubrication. The slightest backlash in the bearings, and the system starts to work with glitches. The hydropneumatic suspension is sensitive to damage. Pierced a hydro line, the tank loses the ability to regulate clearance and possibly will stop dead altogether. The automatic loader is capricious. Now it jams. Now it feeds a missile at the wrong angle. Now it refuses to work altogether. The fire control system requires fine-tuning. The electronics of that time are unreliable, overheat, fail from vibrations. To maintain such a machine, specialists of the highest qualification are needed. But where to get them in mass quantities for the Army? An ordinary tank repairman will not cope with Object 775. Engineers, electronics technicians, hydraulics specialists, specialists in missile systems are needed. Each tank will require a whole brigade of service personnel. In field conditions, it is practically impossible to repair this machine. Something serious broke. The tank stopped and that is it. Evacuate to the factory, disassemble, fix, tune anew. The fourth problem is cost. The machine is expensive, very expensive. Each Object 775 comes out like 3 to 4 ordinary T-64s. Production is complex, requires special equipment, high-precision assembly, specially trained workers. Mass production will cost astronomical money, and considering the low reliability of the system, this looks like funds thrown to the wind. The military begin to calculate. For the same money that is needed for the production of one Object 775, one can release several serial tanks with proven armament. Yes, they do not shoot missiles. Yes, they do not have hydropneumatic suspension, but they are reliable, understandable, easily repaired in field conditions, and, most importantly, they work. Tests continue for several months. Designers try to fix something, tune, improve, change electronics, refine the guidance system, try to improve visibility. But this is patching holes. Fundamental problems remain. The tank is too complex, too unreliable, too expensive, and most importantly, the crew in it effectively sits in a tin can, seeing almost nothing. By the end of 1964, the military commission delivers a verdict. Yes, the tank is technologically advanced. Yes, it is ahead of time. Yes, revolutionary solutions are realized in it, but it cannot be accepted into service. Too many flaws that are impossible to fix without a complete redesign of the concept. And meanwhile, in other design bureaus, they begin to think in another direction. Why create a separate, complex missile tank? Maybe there is a simpler solution, and this solution is indeed found. Only it kills the entire meaning of the existence of Object 775. While Object 775 is suffering at tests, designers of other bureaus think in a completely different direction. The idea is simple to the point of genius. And why create a separate missile tank at all? Maybe one can simply teach ordinary serial tanks to shoot guided missiles from an ordinary gun. We take the T-64, give it a gun of caliber 125 millimeters, and make it universal. It can shoot both ordinary shells and missiles. Separate machines are not needed. A crazy layout with the crew in the turret is not needed. Rotating turrets and hydropneumatics are not needed. The military look at this idea and understand that it works. Indeed, why complicate? We have an excellent serial tank, T-64, reliable, proven, understandable to tankers. We simply give it the ability to shoot missiles, and that is it. A universal gun. See an enemy tank at a long distance? Launch a missile. Need to shoot at a fortification? Take an ordinary shell. Flexibility without complexity. In 1965, they try to shove Rubin into the T-64. They take the base model Object 432. They begin to try the missile complex on the turret. And here, a problem becomes clear. The control equipment of Rubin occupies 200 cubic decimeters and weighs 180 kilograms. This is like 2 refrigerators. Where to shove them into the already tight turret? The ammunition rack needs to be redone. The loading mechanism, change the place for the crew, revise. Plus, the missile with a length of 1.5 meters requires a complete redesign of the layout. It turns out that for the installation of Rubin, one needs to effectively create a new tank. The works are recognized as inexpedient and closed. Rubin is too bulky, too heavy, too complex. But the idea does not die. Designers understand the problem is in the complex itself. A more compact system is needed, and they create it. The new missile complex receives the name Cobra. It is smaller, lighter, simpler in maintenance, and most importantly, it can be integrated into a serial tank without radical redesign. The equipment fits into the turret, missiles are placed in the standard ammunition rack. The fire control system is refined for new capabilities. Everything works without revolutionary alterations. In 1976, the T-64B is accepted into service. An ordinary serial tank with an ordinary 125mm gun, which can shoot both ordinary shells and guided missiles Cobra. A universal gun. A separate missile tank is not needed. Complex mechanisms are not needed. A microscopic crew sitting in the turret and seeing nothing is not needed. Simply a tank that knows how to do a little more. The fate of Object 775 is decided. In 1968, the project is officially closed. One prototype was built, the second started to be assembled, but was not finished. The machine, which was supposed to become the tank of the future, turned into an expensive experiment, which showed that sometimes a simple solution is better than a complex one. All subsequent Soviet tanks T-72, T-80, all modifications received the ability to fire guided missiles through an ordinary gun without abstruse turrets, without hydropneumatics, without a crew of 2 people. The concept of the missile tank as a separate class of machines dies. Universality wins. But the influence of Object 775 remained. The low silhouette as a way of protection. The idea was picked up. The concept of tank destroyers with powerful armament and low height developed further. Hydropneumatic suspension was applied in other projects, simply not in the form as Isakov imagined. All revolutionary solutions were pulled apart into pieces and implemented where they really worked. And now, the most amazing thing about this tank. Western intelligence learned about the existence of Object 775 only after 1991, only after the collapse of the Soviet Union. Before this, the machine remained so classified that there were not even hints of it. No photographs, no mentions, no rumors. Absolute secrecy for nearly 30 years. When American military experts first saw the photographs, they did not believe it. A tank with a height of 174, a crew of 2 people in the turret, a mechanic's turret rotating in the opposite direction. It looked like a photo montage, like someone's joke, but no. Object 775 really existed. The Soviet Union built it, tested it, and closed the project and managed to keep this in secret for 3 decades. The only surviving specimen stands in Kubinka. Flattened, wide, futuristic. A tank that was ahead of its time but did not live to see it. A machine that was a secret for 30 years, and then became a museum exhibit, bypassing the stage of combat use. The Pancake Tank with a turret in a turret, which proved that shoving all innovations at once into one project is a road to nowhere. The simple solution defeated the complex one. The universal gun killed the concept of the missile tank, the failure of which turned out to be more useful than many successes. Like and write in the comments about what absurd military equipment to tell you about next time. Subscribe to the channel so as not to miss new stories.